Hi everyone and welcome to Physics with Mr. Simons, where we make physics simple and we get you exam ready. So today's lesson is focused on Newton's laws. We've taken it from the past exam paper from the Free State, June 2022. We're looking again at a single body, but this time the body is pulled up an incline, specifically with a constant velocity, right? So let's look at the problem. Question 2, my apologies. A 4 kg block is pulled by a constant force F up a rough inclined plane at a constant speed. So that is pulled up at a constant speed. The inclined plane makes an angle of 30 degrees with horizontal there. Force F is parallel to the inclined plane. So F is parallel to that line. 2.1.1 state Newton's first law of motion in words for 2 marks. 2.1.2 draw a labeled free body diagram for the block to show all the forces acting on the object. A constant kinetic frictional force of 12,5 newtons acts on the block. Calculate the magnitude of force F. And then say force F is removed and a block reaches point P. Block continues to move up the inclined plane and comes to rest momentarily at point Q. So P to Q. It's lost basically all the velocity it had from the applied force. Identify the components of the net force in a block as it moves from P to Q for 2 marks. And then 2.1.5, calculate the magnitude of the acceleration of the block from P to Q. So again, as I say, you can pause the video here, try to attempt to answer everything. If it's foreign to you, then work with me through the solutions. But you have to learn to use the solutions so that you can master your content, right? So without further ado, let's start with question 1. Right now, I know you'll know how to study and memorize definitions. So Newton's first law of motion, a body will remain in its state of rest or motion at constant velocity, 1 mark, unless a non-zero resultant force acts on it, or non-zero resultant force act on it, 2nd mark, right? So 1 mark for stating that it would remain in a state of rest or motion at constant velocity, or when a non-zero resultant force acts on it. Right? Now here they said in this problem that the object is moving at constant velocity, so technically we are bringing in first law of motion. Now draw a labeled free body diagram for the block to show all the forces acting on the object. So as the 4 kg is being pulled up, we have the applied force, right? Down, trying to prevent this object from speeding up, going up the incline, we always have friction, right? The 4 kg, we have weight pulling it down, and we have the normal force, right? So they only give marks for those 4 items, right? Now, end of the day, yeah, the arrows must have, or the line must have an arrow to show that you're dealing with vectors, right? So you don't put in the arrow, you don't get that 4 marks. 1 mark for weight, 1 for friction, 1 for normal force, and 1 for applied force. Instead of writing W, you can also write Fg or Fw, force of gravity or force of weight. You can also write for F, force of tension, because I'm pulling with the string, or applied force. For F, I can write Fk, meaning kinetic friction or force of friction, Ff. And for N, I can write Fn or normal force. Now be very careful, we're only giving marks for these 4 items. If you go add extra now and you break up weight as weight perpendicular and weight parallel, they're going to take 1 mark away and only give you 3 out of 4. Right? So those there you bring in later when you start solving the problem, so you know which forces you're all dealing with. But that's the only 4 items we want in the drawing. Right? Let's look at the second or the next problem. Right, now they say a constant kinetic frictional force of 12,5 newtons acts on the block. Calculate the magnitude of force F. Right, now remember they said everything is moving at constant velocity. So technically my forces in the y direction and my forces in the x direction must be balanced. Right, now F is pulling up, weight there, has two components. It has its parallel component or x component and its perpendicular component, y component. So F there is pulling up, but acting against it is friction and FG parallel. Right? Now, before we go further, we need to understand that FG perpendicular, although it's y, doesn't become sine. I know we teach that y is always sine, but now this is the exception to the rule. When you're going up the incline for school physics, the y component becomes cos. The x component that's normally cos becomes sine. So they swap places, right? But you need to know these two equations. When we do with incline problems, we have to work out gravity perpendicular and we have to work out gravity parallel. Right, so to get to F, that's what they want. I need to know F net equal to 0 because I have constant velocity. Ne? So I have my force plus Fg parallel plus F equals 0. But Fg parallel and F is acting in the opposite direction to F, so therefore they become negative and negative. So there, my mass is 4 kg, so minus 4 times 9,8, that's for Fg, and that is sine 30 for parallel. Right, that gives me what? See, 36 and 3,2, 39,2 divided by 2, 19.6. Right, so negative and negative, if I take them over, become plus 12,5, 19.6 plus that, and gives me 32,1 newtons. So 1 mark for Fg parallel, correct substitution, correct formula. Another mark for getting my constant frictional force correctly. Another mark for making it equal to 0. And they are getting 32,1 newtons. Alright, so that's the value of F. Right, now let's go to the next problem. Now, force F is removed when the block reaches point P. So thereby F, that force that we got now as 32,1 Newton, is removed there by P, and the block continues to move up the inclined plane and comes to rest momentarily at Q. So that's some velocity at P. As it went all the way to Q, that velocity there was counted by the friction going down and Fg parallel, so it got to a velocity of 0. Right, now 2.1.4, identify the components of the net force on a block as it moves from P to Q. So there's no applied force going from P to Q, so the only thing that's working on it, friction, which is trying to slow it down, and weight parallel or Fg parallel. So there, weight parallel or force of gravity parallel, friction or kinetic friction. Or you could have written it in words. Makes no difference. 1 mark for each one, 2 marks. Right, 2.1.5, calculate the magnitude of the acceleration of the blocks from P to Q. Right, so there was acceleration, so F net equal to ma. Right, going from P to Q, the only two forces that were working, Fg parallel and friction, equal ma. They were working in the same direction. So Fg parallel, remember, is m times g sine the angle, which given there is 30 degrees. No? Sine 30 plus 12,5 equal my mass, which is 4a. That totals 32,1 divided by 4 gives me then 8,025 meters per second squared. So my magnitude here equal 8,025 meters per second squared of acceleration from P to Q. Right? So that is 4 marks, 1 for correct substitution, 1 for correct substitution of mass, getting division properly and getting correct answer and specifying the magnitude. So I hope you enjoyed and understand what I've explained. Continue practicing. Wish you nothing but the best. God bless. Bye.